Hi everyone, today I'm just doing a quick review of function notation, two different ways, so that you're getting yourself ready for standardized tests. So let's just talk about function notation and how to read it. So back in Algebra 1 you learned that a linear function could be written as y equals 2x plus 5. Okay, so that's the old way. The new way would be to write it as f of x equals 2x plus 5. So f of x is another way to write y. And f is not a variable. It means the function at x equals 2x plus 5. So it's really important for you to remember, if it's a function, this is the input and this is the output. F of x is equal to y. So input, output. Now, if that's true, then let's talk about coordinate points, okay? So coordinate points then, the old way would be to write it maybe something like 2, 1. In function notation, 2, 1 would be written f of 2 equals 1. Okay? Now, what if I was asking a question and I said, okay, y equals 2x plus 5, find y when x equals 2. Well, now I would say f of x equals 2x plus 5, find f at 2. That means you are going to take 2 and make it your input and make it your x. You're going to plug it in to 2x plus 5, so that's going to give you 4 plus 5, which is 9. So 2, 9. So the point 2, 9 is on the graph. All right, so let's talk a little bit more about that. Okay, so I just gave you some general functions. Y equals f of x equals c. So c in this case is a constant. So normally it would be written as y equals c. Which is a degree 0 polynomial, and it is a constant function, which means it's a horizontal line, okay, a horizontal line. Y equals mx plus b, or f of x equals mx plus b is degree 1. It is a linear function. Remember, we're always looking at the exponent of x. Y equals, or f of x equals ax squared plus bx plus c is a degree 2 polynomial. It is a quadratic function. And f of x equals ax cubed, that would be degree 3, which would be a cubic function. So I just wanted you to see that instead of y, we're going to be using f of x. That's function notation. And that's how it would be used in an equation. Okay, well, let's look at it in a more complicated function, okay? This is called a piecewise function, meaning it has pieces of different functions. In this case, there are 2 functions. Now, they're written together, but I want you to think of this as f of x equals x is part of the function, and f of x equals x squared is another part of the function. However, we're only looking at part of it. So for x, we're looking at it only when x is less than 0, and x squared, we're looking at it when x is greater than or equal to 0. So if you're trying to evaluate it, we call this the domain. First, you have to find which domain you're looking at it, and it will tell you which function you're going to apply the point to. For example, f at 0. Okay, so f at 0 means f is 0. So that would be in this interval right here. So f at 0, we'd plug it at 0 in for x into x squared, and we would get 0. So f at 0 equals 0. So f at 10, it's in this interval as well. So I'm going to plug it into this function, so 10 squared would give me 100. Okay, f at negative 3 plus f at 5. Okay, so now this is actually asking me for 2 different things. F at negative 3, so x is less than 0, would be this one. So it would just be negative 3. F at 5 is in this interval, so we would square it, so 25. And so that would give me 22. So f at negative 3 plus f at 5 is 22. Okay, -3 times f of 1. When there's no symbol there, it's multiplication. Again, f is not a variable. It is the function kind of name. All right, so at -1, I have to look in the first domain. So that would just be -3 times -1 times f of 2. 2 gets plugged into x squared, so 4. So that would give me 3 times 4, which is 12. Okay, 7 minus f at -5. Well, -5 is in this domain. I plug it in. So that's going to give me 7 minus -5. So 7 plus 5, which is 12. Okay, so function notation can get tricky with piecewise functions. So again, look at your domain carefully and then find the what x they're looking for, which domain it fits into, to identify which function you're going to use. All right, I really wanted to spend today working on functions graphically. So that was functions symbolically, so as an equation. Functions graphically and function notation graphically gets a little bit tricky. But if f is a function, then f of a equals b is equivalent to the point AB, like I just said. So a comma b is the coordinate point on the graph. So if I give you a function like this, f of x, and I see the 1, 3, another way to write that is f at 1 equals 3. Remember, f of x equals y. All right, let's look at it a little bit, with a real graph here. So I want to find f at -4. So that means I've got an x of -4 and I want the output. So -4 is my input. What's the output? So I go to x of -4. I find the y on the graph, which would be 2. So -4, 2 is the coordinate point on the graph, okay? F at 0, okay? So I go to an x of 0, which is right here. My y value would be 0. F at 3, 1, 2, 3. Okay, so that's about -1.75 I'll go with, okay? F at -5. All right, so I'm going to the x of -5, and I can see that the y is 0. Paying close attention that that's the special point, the x-intercept. It's another x-intercept, as is this one. This is both the x-intercept and the y-intercept. All right, making it a little bit more complicated, how many places is f of x equal to 2? Okay, so it's not giving me x this time, it's giving me the output, it's giving me the y. All right, so here's 2 on the axis. Well, f of x equals 2 here and here in 2 places. And that can happen. We can have multiple y values, just like we can have multiple x values, okay? All right, but what if I said something like this? If A is the point marked in red on the graph, so let me mark a red point on the graph. I'm going to mark it right here. If f of A is the point marked in red on the graph, how many places does f of x equal A? Well, you're looking for the x values where the y coordinate would be A. Well, the y coordinate would be A here and here. So that means, again, there would be 2 places on this graph. It's sometimes hard when you're given the y to think about what they're asking you for. So I just want you to pay close attention to that. All right, so let's get really careful here. Using the graph shown, evaluate f at c. Okay, so f at c is the x, which means that I want the y. Now, I go to c and I go up here. Now, you'll have a tendency to want to say it's L. But L is the coordinate point itself. The y coordinate is t. So f of c equals t. All right, solve f of x equals p. Okay, so I know that my p is the output. So I find p on the graph right here. And so f at 0 equals p. So x equals 0. All right. Suppose f at b equals z. Find f at z. Okay, well, f at b is right here because b is x. And so z is actually 0 because it's the x-intercept. So that means I want to find f at 0. Well, f at 0 is r. See how tricky it can get when they're letters and not numbers? Okay, now what are the coordinate points of L and K? I say L would be C comma T, we did that one already, and K would be A comma P. You might be saying, Coach Fred, why am I not calling that negative P? Well, because they gave it the name P. They gave that negative point the name P. So it is a negative value. They just gave it a positive name, okay? All right, let's look at another couple graphs. All right, so this is composition of functions. When we're asked to evaluate, you always start with the innermost function. Now, I gave you two different graphs. I carefully see one is F and one is G. So it says find G at 3. So I'm going to do G at 3 first. So G at 3 is 4. That means that I want F at 4. So F at 4 is 0. So F of G of 3 is equal to 0. All right, let's look at N. G at 1. G at 1 is 3, right? Because the X is 1, the Y is 3. So that means I want to find F at 3. F at 3 is 2. So that means F of G of 1 equals 2. Making sense? Let's try another one. F of 1. Okay, so F of 1 is 3. So I want to find then G of 3. So G of 3 is 4. So G of F of 1 is 4. Make sense? Okay, F of 0. So F of 0 is 4. So then I want to find G at 4. G at 4 is 5. So G of F of 0 is 5. Okay. I'll leave these extra ones for you to try on your own if you need to practice. Okay, we're going to look at a couple more complicated ones. I know this is a little bit longer, but I really wanted to get this all in. Okay, I gave you a graph and I didn't label any of the points along the x-axis. I did give you units here, and I'm going to tell you that this is 1, 2, and 3. Okay? All right, so what is h of b? Because this function is h of x. Okay, so h of b, so here's b. H of b is equal to 0. Okay? Why? Because the y-coordinate is 0 when the x-coordinate is b. So what is h of a? Well, h of a is some negative value, isn't it? Let's say 1. I'm sorry, negative 1. Okay? So h of a equals negative 1. Because it's asking for the y value when x is a. Okay, what is h of 0? H of 0 equals 3. All right, and then it says fill in the blank. H of a blank h of b. Well, how do we compare h of a and h of b? Usually questions like that are asking you to compare them. Well, if h of b is 0 and h of a is negative 1, then h of b is greater than h of a. So points can be greater than or less than other points. That's true, right? The lower we go down, the smaller the value it has. All right, let's look at another one. F of x is shown. If h of x is equal to f of x minus 1, what is the x-intercept of h of x? Okay, so I first want to find the x-intercept of f of x. Well, x-intercept of f of x is 4, 0. Well, h of x, it's saying we're doing something to f of x. We just have to remember what that means. That's on the inside of the function, so it's always going to shift it left or right, but in the opposite direction. So this is going to be shifting that point right 1. So h of x's x-intercept would then be 5, 0. All right. One last graph, okay? One last graph. The figure above shows the graph of f, the function f, and the point negative 4b. For how many values of x between negative 5 and 5 does f of x equal b? Okay, so we go to our f of x graph and we're looking for how many values where the y coordinate will be b. Okay, well, it's going to be here, 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 and here. So for how many values of x? For 4 values of x. All right, so that was a really quick review of function notation graphically, which can be the trickiest. Next time I'm going to be going over function notation in tables and descriptively. All right, have a great day.